Hi ladies and gentlemen, this is Miss Jermaine. I'm putting up a video of me going through some more problems that were like the ones on the slides for lesson 10. This is going to be probably a pretty long video, so if you want to skip around, please feel free to do that. But I'm going to go through all of these examples, talking through all the steps that I have to do here. So if I'm looking at number 1 here, okay, I have 5 to the x is equal to 125 to the 3x minus 3. So if I look at this guy here, I have a nice small number that I know that when I multiply or when I square it or cube it or do something to it, it's going to get me 125. So I'm going to keep this base of 5. So this is going to be equal to 5 to the x power. And if I want to say I have this 125 is equal to 5 to the 3rd power. And then I have to multiply that by this exponent, 3x minus 3. And I want to make sure that I remember that I have to do my distributive property, which means I have to multiply by the 3x by the 3 and the minus 3 by the 3. So when I do that, I'm going to get my next line, which is going to be 5x, we still have 5 to the x, is equal to 5 to the 9x minus 9. So since these have the same bases, these cancel out now, and I'm left with just x is equal to 9x minus 9. Okay, so then I just have to solve it like I would any other math equation. I would have to bring my x's over and isolate my x's. So I need to subtract 9x from both sides. Okay, and I have x minus 9x is going to get me a negative 8x is equal to what's left on the other side is a negative 9. I have to isolate my x, so I have to divide both sides by negative 8. Divide by negative 8. I'm going to be left with x is equal to 9 over 8. And we know that this is going to turn into a positive 9 over 8 because we have a negative divided by a negative, which is going to give me a positive. Very good. That was number 1. Let's take a look at number 2 now. I'm going to fold my paper. Let's take a look at number 2. Number 2 is written as 9 to the 5x plus 1 is equal to 1. And remember that 1 can always be rewritten as 9 to the 0, if we remember. And we can rewrite the other side as 9 to the 5x plus 1. Put it in parentheses. Because we have our same bases, our bases cancel out, and we're left with 5x plus 1 is equal to 0. Now I need to isolate my x. I have to subtract 1, subtract 1. I'm left with 5x equals negative 1. I have to isolate my x here, so I have to divide by 5, and I'm left with just x is equal to negative 1 over 5. Boom, there we go, number 2. Let's take a look now at number 3. Number 3 has 6 to the 6x is equal to 36 to the 2x plus 1. So I have to say to myself, oh geez, I like this 6 here. This 6 is a nice small number, and I know that if I square 6, I'm going to get myself a 36. So I'm going to keep this 6 to the 6x on the left side. And then on my right side, I'm going to say to myself, I have 6 to the what power gets me 36 to the 2nd power, and then I bring down my parentheses. Okay, and then I remember I have to make sure that I distribute this 2 to both pieces here. You need to distribute it to the 2x and to the plus 1. So when I distribute it, I'm going to be left with 6 to the 6x is equal to 6 to the 2 times 2x is 4x, 2 times 1 is 1 plus or plus is equal to 2, I'm sorry. And because we have our same bases here, our bases cancel out, and we're left with our 6x is equal to 4x plus 2. Now I have to isolate my my x by minusing 4x from both sides. Okay, I'm going to be left with a 2x is equal to 2. Isolate my x again. I have to divide by 2, divide by 2. I'm going to be left with an answer of x is equal to, that's a pretty stingy x, is equal to 1. Let me rewrite that in a darker color so that we don't write down the incorrect number there. We have is equal to 1. Okay, now let's take a look at question number 4. Okay, so when we start with number 4, oh goodness, I have some pretty big numbers in both of these pieces here. So the first thing that I'm gonna write a few notes over here. So I know that my right side is gonna have to be a negative exponent because I have a fraction here with a numerator of 1. What I'm also going to think about is, oh gosh, what number goes with both of these guys here? Oh, I know that 4 squared gets me 16. And then 4 to the third power is going to get me the 64. Oh, okay, so I'm going to convert these both to a base of 4. So if I convert this guy to a 4, it's going to be equal to 4 to the second power. And then I have my parentheses of x plus 2. Okay, and we're going to say that it's equal to, okay, so what did we say? That it was 4 to the third power gets me this 64. But, wait, I'm sorry. Let me write this. 4 to the third power. But, ooh, okay, if I remember back here, it has to be a negative third power because we have a fraction with a 1 in the numerator. So we have a 1 in the numerator, so it's going to have to be a negative fraction here. So I have this guy here. So now I have my common base. I have a 4 and a 4. They cancel out. I'm left with, I have to distribute. 2 times x gets me 2x. Plus 2 times 2 is 4, is equal to negative 3. Okay, so now I have to get this x isolated. So I'm going to subtract 4 from both sides. I'm left with negative 3 minus 4. That we're going back on the number line. We're going to say is equal to negative 7 is equal to 2x. Okay. Ooh, am I done? Ooh, I don't think so. I still have a 2 attached to this x here, so I have to divide by 2. Divide by 2. X is going to be equal to negative 7 halves. Remember, please don't lose your negative sign here. I saw a couple people that when they were rewriting it, like from step number 1, 2, 3, 1, 2, 3, 4, 5. Like, so from step number 5 to step number 6, I saw them losing that negative sign. You need to keep this negative sign with it. Okay, so those are the first 4. Let's take a look at our next one here, number 5. Okay, let me just get it centered in my paper here. Okay, so I have another fraction here. I'm going to make another note on the side. I have a fraction. Means I have a negative exponent. Okay, really important. So I have this 1 to the 5th. Ooh, 1/5, right? Okay. So remember that when we have a number here that's all by itself, we can always imply that there is a 1 here attached to it, a 5 to the first power. So if I have this fraction of 1 over 5 to the first power, if I know that I need to reciprocate it and give it a negative sign to create my negative exponent, I need to do that. So I'm going to say to myself, this is converted to 5 to the negative first power. It's sort of like in that activity we did the other day where we went from here to here, but now we're going backwards. We're writing a fraction as a negative exponent. And then with that, I have to bring down my parentheses. I have my x plus 3. And then we're going to say that it's equal to 5 to the 2x minus 1. Okay, so now I have my common base again. Before I get started, I need to distribute my -1 to each piece here. I have -1 times x gets me a negative x. -1 times 3 gets me a -3 is equal to 2x minus 1. Okay, now I need to isolate my x here. So I'm going to add an x, add an x. I'm going to get a 3x minus 1 is equal to -3. This is just one way that you can do it. You could have brought this 2x over, or you could have brought the 2x over and then brought the number over to the other side. Both ways work. I'm going to add 1 to both sides. I'm going to be left with -3 plus 1 gets me a -2 is equal to 3x. Have to divide by 3 to isolate my x. I'm going to get x is equal to -2/3. I'm going to say it again, just like I said with our last example. Please do not lose your negative sign. It's going to be really, really not cool if you get it wrong just because you didn't put the negative sign. When we go through and we're doing our assessment next week, we're going to put trick questions on there where if it's going to be 2/3, we're going to say it's -2/3. And then you want to make sure that you don't lose your sign anywhere along the way, okay? So let's take a look at number 6. Okay, so I have number 6 here. It's a little bit in the dark, but it's okay. So we have number 6 here. And, oh no, once again, we have some bases that are kind of crazy. I'm not a big fan. I don't know. Okay, so this time, we're going to say to ourselves, ooh, okay, so we have a 16. I know that's like 2 to the 4th is equal to 16. Oh, and I have this 32, which is, I know this times 2 gets me 32. So, okay, so I might have to convert these guys to a base of 2. So if I convert this to a base of 2, this would be 16 is equal to 2 to the 4th power. And we have to remember, multiply what's already in that exponent. And it's going to be equal to 2 to the, okay, so this times 2 more would get me 32. So it would be 5 times 3x plus 3. So now on both sides, I need to distribute. The first side's easy because there's no constant there. But on the second side, we need to distribute to both pieces here. So 4 times 4x gets me a 16x. And our bases are going to cross out. Sorry, guys, I forgot to say that. And then we're going to distribute here, and we're going to have 15x plus 15. Okay, so now 15x is smaller than 16x, so I'm going to subtract 15x from both sides. I'm going to get 16 minus 15 gets me a 1x, or you could just write it as an x, and I'm left with my 15, so I can simplify it and say x is equal to 15. Okay, there we go. That's number 6. Let's take a look at number 7. Okay, not too much in the shade there. Okay, so I need to think back. Oh, okay, so I have some multiplication here. Okay, so that means that because they have same base, I know that I can use those rules from lesson number 7. And those rules from lesson number 7 was if they had the same base plus you're multiplying, you add exponents. So that means I'm going to keep my base of 3, and I need to add the exponent numbers. So I have a 4x, and a 2x, which would simplify to a 6x. I don't have a constant on this first one, so I'm just going to have to plus my 6x, plus my 3 to both sides. Good. And now I need to say to myself, 243. How can I rewrite that number as a how can I rewrite that number as an exponent? So I need to say to myself, I have a nice base of 3 here. So that means this guy's probably going to be in some way divisible by 3. So what you're going to have to do, what you might have to do is take your calculator. Let me show you. Right? And you might just have to do some guess and check here. Okay? So you could say 3 to the 5th power. You could say, and that actually got it perfect. So I said 3 to, no, wrong button, sorry. 3 to the 5th power, and that gets me 243. So that means I can rewrite 243 as 3 to the 5th power is equal to 3 to the 6x plus 3 power, right? So then I have my common bases, so I can cancel them out. I'm left with 6x plus 3 is equal to 5. Isolate my x by subtracting 3. Subtracting 3, I get a 2 is equal to 6x. Okay, divide by 6, divide by 6. This can be simplified to x is equal to 1/3. We want to make sure that we're writing these as fractions. Don't give me decimals, because decimals are not always 100% decimals aren't always, so if you have a non-terminating number, for example, 1/3, if you say 1.333, that's not going to be 100% correct. Okay, so let's take a look at our last example here. Okay, so we see this guy here. Oh, goodness. Okay, so once again, we don't have the same base on, we don't have a common base on each side. But I look at my numbers, and I need to be a mathematician here, and I need to say to myself, geez, I have this number 49, and I know that's a perfect square, like a perfect square, right? So I can say, I know that 7 squared is equal to 49. So I can rewrite this 49 as 7 squared, and then I have to multiply it by that number that's already in the exponent there. Okay? So then if we said we had a 7, a base of 7, so that gives us a pretty good inclination that this 2,401 is also going to be 7 to some sort of power. So like we did with our last one, we're going to do the same thing. And we're going to have to do some guess and check here. We're going to have to find 7 to what number is going to get me 2,401. So let's test out some numbers. 7 to the 3rd power. Okay, not big enough. 7 to the 4th power. Ooh, look at that. 2,401. So 7 to the 4th power is going to get me there. 7 to the 4th power times it by my 2x. Okay, so now I have my common bases. They cancel out. I'm left with distributing my 2, distributing my 4. When I distribute my 2 to my 3x, I get 6x. When I distribute my 2 to my -3, I get a -6. Okay, when I distribute my 4 to my 2x, I get an 8x. Okay. So then now I need to bring my x's over, so I have to subtract my x, subtract x, subtract your 6x, sorry, and you're left with 2x is equal to -6. Okay, so then to get my 2 isolated, I need to divide by 2, divide by 2. This time I can rewrite this number as a -3 is equal to x. Okay, remember, do not lose your negative sign. I am going to try to trick you when we take our assessment, and I'm going to throw a 3 there, and I'm going to throw a -3. You need to make sure that as you go through, you keep your sign. Okay, so ladies and gentlemen, I hope this video helped you. It was very long, I understand, but I think in the long run, it'll be good for you guys. Okay, have a good day, guys. Bye.